On April 20th, 2010, BP's test well gushered, releasing petroleum. Methane bubbled up, ignited, and killed workers. Then the pipe, almost a mile long, fell to the bottom, breaking in 3 places. What should have happened on April 21st or soon after? A beaker experiment is a small step on the way to answer the question. A magnetic stirrer is throwing water out to the wall. It goes up the wall, back to the center where it forms a little dimple as the water is sucked down into the stirrer. Add oil, color with Sudan yellow, and the dimple becomes a cusp, where the oil guides the water down and the water pulls the oil down. It's much larger. Focus on the essentials and ignore the irrelevant and wrong aspects. We want to sweep each 1,000,000 gallons of oil into a pool from 1 centimeter to 1 meter deep. The areas would be 0.39 square kilometers. That would be 0.15 miles square for 1 centimeter deep. The radii would be 35 meters, even for 1 meter's depth. Ignore the magnet, the beaker, and the small amount of horizontal rotation. The important part is throwing the water out from under the oil, and it will be done near the periphery, not near the center. We need not a small cusp in a beaker, but a broad pool holding 1,000,000 gallons. Drops of oil got away during pouring. Follow them to see the water movement and coalescence of the drops. Pete Seeger sings, "And when drill baby drill turns to spill baby spill, God's counting on me, God's counting on you. There's big problems to be solved, let's get everyone involved. God's counting on me, God's counting on you." What if half a dozen fishing boats began sweeping up the oil the next day or so and held it in a pool downstream of the leak until a tanker came and took it to market? The oil would be theirs to sell. The other fishing boats could continue fishing, and pensions, depending on BP, would get their dividend. BP could take the time to seal off the test well properly. The fishermen did not know what to do to use for brooms. Skimmers were not the answer. The easy and efficient way was to drag underwater impellers under the target area to pull the water out and pull the oil in on the surface. Let gravity and minutes coalesce oil drops into the rest of the pool. The oil pool could either be deep enough for a tanker to pump the oil in without water, or deep enough to drain into a sinkhole for pumping. And collecting the oil in a pool the day after a spill would mean that effective impellers would be ready somewhere in the world to be flown to the site of the incident. They would probably be flexible and folded like paragliders to be easily carried. To be effective, they would need to be designed and tested for the purpose, and boatmen trained to use them. At the site, they might be beefed up with stiff-shaped sections made locally. This is the first of 4 YouTube presentations on what to do to be prepared to capture the next leak. This, the first one, is a demonstration using water and colored corn oil being stirred in a beaker using a magnetic bar. The second one will go into more detail about what we can do with the beaker in the laboratory and about what surfers know about deep water waves. Then I will do some hand waving, what we want to do with 1,000,000 gallons of petroleum. The third one, which may be critical to you or of no interest to you, will be about technical and scientific questions, such as the potential energy of oil spreading, the kinetic energy available from a gallon of diesel, how to use a pair of impellers to accumulate momentum in a water torus, which keeps moving the oil back into its pool, and why surfers don't ride deep water waves. The fourth one will be addressed to boatmen who know much better than I do about using boats under various conditions and towing something behind them to do what they want to do. I am also preparing a PDF paper to cover more detail. I got the idea in the 1960s when a storm in the Sea of Japan ruptured a tanker. A storm moves on, leaving seas that boats can cope with. Waves have problems coping with oil. My delay since April 21st has been in part from expanding the concepts. Beaker tests have taught me the advantage of a beaker wall to help store the momentum circulation. Using a second impeller at the surface, pushing water in, could build up momentum into a circulating torus. It could also balance using a third cable, the force from the first impeller in deeper water under the pool. That is, throwing water out. The surface flow in and the deeper flow out make the flow into a torus or donut. What about the next time? The law will prevent the next time, sure. The law may prohibit an oil spill, but will that prevent the next time? We need a better solution when the law fails. Regarding the law, Pete Seeger sings, "When we look and we can see things are not what they should be, God's counting on me, God's counting on you. It's time to turn things around, trickle up and not trickle down. God's counting on me, God's counting on you." Let's start a new beaker experiment called Red-Green Fast. It's fast because we just pour the green dye solution in, and it reaches the bottom quickly, and we soon have threads of colored water, green colored water, and then we will switch from there to the magnified view until there is enough green going out to the outside, spread through the whole beaker, to make a significant color of the solution as a whole. Then we come back to the unmagnified view, where you can see the surface as well.